Okay, let me start with my first vocabulary term, and that is what a transversal is. A transversal. If you have two lines, like I do M and N in your diagram, I have lines M and N. If a line intersects those two in two spots, that's called a transversal. So my line P here, line P in this diagram, is what I consider a transversal because it intersects two other lines in two spots. So I just want you to become familiar with that. When I draw the transversal in, everyone see I formed 8 angles and I've labeled them 1 through 8. My goal today, you can identify them as special types of angles. Not a true story, but just to help us here. Let's say over this long 4-day weekend we had, I redid some of the interior of my house over this 4-long-day weekend. Where was I doing work then? Inside the house, right? So anytime I see the word interior come up today, I'm thinking looking in between the two lines that are getting cut by the transversal. Okay? So interior, in between. Well, what if I was doing work on the outside? You'd say I'd be doing work on the exterior, yes. That word will come up often. So if I'm seeing the word exterior, I want to look outside the two lines that are being cut. All right, let's look at the first type of angles in number 1 and see if we can pick out which numbers represent that. Alternate, there's a word again, interior. So where am I looking? Inside. So it's got to be something with 3, 4, 5, 6, right? 3, 4, 5, 6. Alternate interior angles. Now let me go to the other word that's with it. Alternate. What the alternate means is, remember our transversal P? Those angles are on alternate sides, opposite sides of them. Okay, they're not on the same side, they're on alternate sides. So I'll give you this one, you give me the other pair. A pair of alternate interior, angle 3 and angle 6. Do you see how they're inside and on alternate sides of the transversal? Does everyone see that? Where I'm getting that from. All right, that's not the only pair. That's just to separate them. That has nothing, no crazy symbol here. That's just to separate them. And the other pair, 4 and 5. Okay, 4 and 5. Those are called alternate interior. What's up?
Did you say 4 and 3?
No, I cannot. Though we do have a name for them though.
No. Supplementary.
Help the poor guy out.
Seems like you.
No. Don't even look. Don't even look. You already know it. From units 1 and 2.
Oh, linear pairs.
Yeah, all right. Yeah, they're linear pairs. Good. Yeah, so we already had a name for them. Yep, they're linear pairs. But yeah, I could see how you would call them alternate interior, but no, linear pairs. We got a name for them. Also, this is very elementary schoolish. Maybe I shouldn't be showing it to an honors level here, but if you ever need help finding alternate interior, I always look for the letter Z. And again, this is why it's elementary schoolish. What's the Z eat up? If I close it, 4 and 5. And if I did a backward Z, what's the Z eat up? 3 and 6. So alternate interior. I always look for, if I see a Z somehow, a Z pattern, I know there's alternate interior angles involved. All right. A little elementary schoolish, but it might help you. All right, next pair, alternate exterior. Just by the name alone, can you figure out what angles I'm looking for here now? Alternate exterior. Outside and opposite sides of the transversal. So anybody want to give me a pair? Go ahead, Ziv. What do you have? 2 and 7. Outside and on opposite sides of the transversal, along with 2 and 7, and what else do I have? 1 and 8. I'm going to skip over corresponding because they don't have any of the vocab in there. So let's keep, I'll do that last. All right, the corresponding. Let's go to number 4, same side interior now. What do you think? Same side interior. Think you can identify at least 2 angles that would be considered same side interior. Anybody confident? Same side interior? Something like, what do you got?
Angle 4 and angle 6.
It's 4 and 6. Yep. And then how about on the other side, 3 and 5, everyone? All right, same side exterior now. What do you think? Anybody think they got a pair of same side exterior? Come on. Same side exterior. Let's go, Gian. Darn right. Angle 2 and 8. And can't leave out also 1 and 7. All good. And I just want to remind you, I probably should have wrote linear pairs too, but we have vertical angles up here. Let's not forget about those, right? We got pairs of vertical angles, so I'm just going to write one pair. Let's go 6 and 8. Don't forget about those. Just to remind everybody. All right, can we go back to number 3 now? Corresponding. Where the heck are they? Because I don't see alternate, I don't see interior, I don't see same side. Where are corresponding? Here's the easiest way to remember. Everyone see the 4-pack of angles up here? Slide them down onto the bottom 4. Which angles correspond to each other? What angles match up? All right, if I move either one up or down, which angles match up? What would angle 1 match up with? Angle 1 and angle 6. Yep, so they're corresponding. We could do 3 more pair, but let's just do 1 more. Give me another pair of corresponding now. 1 and 6 and... That's what I thought. What's up, Gabby? You got it. 3 and 8. There's a good pair. And again, we could do 2 more, but I think we're good. Whoa, I'm not done here. Relax. Okay, step 1 is, what type of angles are they? Step 2 now, we're going to move on to, what do I know about them? Because all these angles are either congruent or they're supplementary to each other. Whoa. I think you already know. What do you know about this? What do you know about vertical angles? They are congruent. So you already know that. But what about the rest of them? Are they supplementary or are they congruent? Let's find out. Let me introduce you to parallel lines now. Yes, I know, lines that don't intersect. From Unit 1, can we review this quickly? From Unit 1, what's the symbol for parallel? So I don't have to write out the word parallel every time. Anybody remember that symbol? 2 vertical lines. Perfect. Now, how do you show that on a diagram that they're parallel? Right? Because if 2 segments are congruent, we got hash marks. 2 angles are congruent, we got arc marks. How do I show on a diagram my lines are parallel? Arrows. Arrows on the lines that are parallel. So you will see that going forward. That represents the lines are parallel. All right, so what do I know now about all these special angles? Are they congruent? Are they supplementary? Let's start with the alternate interior angles. On my diagram, give me 1 pair of alternate interior angles on this diagram. Again, don't look back. Just use the name. Alternate interior. All right? Alternate interior. Give me a pair of alternate interior angles on my diagram. Whoa, I got a couple of these going, huh? Ian, give me a pair.
3 and 5.
3 and 5. If the lines are parallel, any alternate interior angles will be congruent to each other. Okay? So 3 and 5 are congruent, so are 4 and 6, but not all 4 together. Corresponding angles. Give me a pair of corresponding angles in my diagram. Haley?
1 and 5.
1 and 5. They are congruent. So far, alternate interior angles are congruent, corresponding angles, and the last pair that will always be congruent are alternate exterior. So give me a pair of alternate exterior in this diagram. Thomas?
7 and 1.
7 and 1. Yep. So those are the pairs that are congruent. And the way I always remember it, if you want a little secret, anytime I hear the word alternate, they're always congruent. And then you do have to remember corresponding, right? But anytime I hear the word alternate, they're congruent. Well, what about the other types we talked about? Those will be supplementary, including same side interior. Same side interior. Give me a pair of same side interior angles on our diagram. Olivia, same side interior. Yep, be confident. So now watch, I'm not going to put the congruent symbol. I'm going to say 3 plus angle 6. You guys know what supplementary means. What am I going to set it equal to? I'm going to set it equal to 180. And then same thing applies for same side exterior angles. Same side exterior. Give me a pair. Same side exterior angles. Thomas, back to you.
7 and 2.
7 and 2 look good to me. So angle 7 plus angle 2 equals 180. All right, before we get into the algebra problems, quick review. Anything says alternate, they're going to be congruent. Anything says same side, they're going to be supplementary. Okay, anything that says same side, supplementary. Anything that's alternate, congruent. All right, let me start you with the basic one. First, do you all see the diagram with the arrows? So even though I didn't give it to you, the diagram tells you, because of these arrows, that those lines are parallel. I am giving you that this angle is 75. I don't care which angle you find first, but I want you to find angle 1 and 2 in your groups right now in about 45 seconds. Do not put any justification yet. Just find the angle measure in degrees. Talk it over in your group. Go ahead, 45 seconds. Good talk. Oh, we're good already? All right. Anybody? Anybody want to take one? Angle 1 or 2? I don't care. What do we got here? This crew. Come on now. For which one? Angle 1. How'd you guys get that in your own words? That's a mouthful for me. I don't want to. I don't want to. Yeah, it is your bad. I don't want to have to write all that down. I just want a quick theorem. Hey, yeah, let's go. Let's go. Linear pairs are supplementary. Yep. Oh, wait a second. So you don't have to use a parallel line fact every time? No! You guys got to keep remembering. Just because we're done with unit 1 and 2, they still are here. They still exist. Use it. Anything we've talked about, keep using it. How about angle 2? Now you're going to have to use a parallel line fact. Hello, Josh.
Corresponding.
So you're telling me because that was 75, angle 2 had to be 75. Yes, because they're corresponding. Now, here's my reasoning, and this is the same reasoning we will use tomorrow when we restart proofs. Parallel lines, because that's what I was given. Parallel lines. And now, I don't know if you guys have used this in the past in your science class, the arrow implies. That's what that means for me, implies. So if you have parallel lines, that implies, what type of angles were they again, Josh?
Corresponding.
Okay, yeah, think about that, right? Corresponding angles are, and now are they congruent or supplementary? Congruent. And this is going to get repetitive, and I want it to get repetitive today. You're going to always start with perpendicular lines imply the type of angles and then what you know about them. That's how all this justification will work today and tomorrow in your reasons column. Questions? I am very confident you can always handle a diagram that looks like this. Where some of you may start having issues is that diagram doesn't look like that anymore. So look at number 2. Everyone sees the parallel lines I've given you. Find x and y. Woo! Well, I think we're all in agreement we're not going to mix x and y together in the same equation. That'll be chaos. So how about we just focus? Let's focus on the two angles that have a y in it. Let's focus on these two bad boys. Can we figure out what type of angles they are? Well, let's start here. Are they inside or outside the parallel lines? Inside, right? So it better have the word interior. Are they on the same side or opposite sides? And if you don't know what I mean by that, here's your transversal in this case right there. Are they on the same side or opposite sides? Okay, so you just told me they're interior and same side. Can we put the two together and make? Same side? Interior angles, yes. Now, are they congruent or supplementary? Same side, interior. Congruent or supplementary? Okay, there we go. So we're going to take y, and we're going to add it to y minus 50 and set it equal to 180. That's how this process goes today. What type are they? Congruent or supplementary? All right, that's how this process goes. Okay, solve it. Use your algebra skills. That's why you're in here, right? Because you're just so masterful at algebra last year. 2y equals 230. Oh, good thing we got those calcs. And y equals 115. We need a justification, though. Okay. It's going to look just like we did up here. Parallel lines imply, but now, what type of angles were we just dealing with? I don't want to put corresponding because they weren't. Same side interior are, and then tell me if they're, what were they again? Supplementary or congruent? Supplementary. Okay, it's going to be the same routine every time. Tell me what type of angles they are and what you know about them. All right, what about the other two now? This 2x angle and the 90 degree angle. What type are those angles? Congruent. You better back yourself up. Why?
Both
Don't
like supplementary, but they're like the same too.
What type of angles are they? Inside or outside? Same side or alternate? So they're same side again, aren't they? So what should I know about them? They equal, add up to 180. You're getting there, Josh, yes, but I want to make sure everyone realizes that they add up to 180. But yes, they do end up being congruent here just by coincidence. .45 degrees for, or not degrees, just at 45 for x. And reasoning, well, we don't have to write it over, but it would be the same justification, right? Because they're same side interior. All right, I'm going hands off here on this next one. You and your group find x and y for me. Woo, here we go. I'll give you a little extra time on this one. Find x and y. You guys see which lines are parallel. Find x and y. Any group confident in either of the two variables and you want to start? We're not confident. Doyle, what about your crew here? Oh boy.
Angle x equals 70 degrees.
Okay, so hold on. That is correct. Angle x is 70 degrees. How'd you get there?
Because corresponding angles are congruent.
Nice job. I'll write that in a second. A lot of people don't see that x and 70 are corresponding because they see the 50 and the y here, and they don't see the x and the 70. Watch. Little magic for you. Let me get rid of that for you. Make it a little easier on the eyes. Best I can here. you see now how the X, if I shifted it down, would correspond, match right up with the 70? Yes, that is true. So my reasoning, and again, you could have gotten there a different way, but parallel lines imply corresponding angles congruent. Yep. Good job. So now that's 70. And I'll take over from here. Now to get Y, there's a couple ways you could get Y. Now that you have the 70, you could say all three angles add up to 180. All right, why don't I want to use the word supplementary there, though? So this is 3. Supplementary is only for 2. So I could say 180 minus both of those angles gives me 60. And probably I'd want to use a reason like straight angles add to 180 maybe. I do not want to say anything about supplementary, though. And then the other way to get to it, which I saw a couple people do, is, hey, you see that 50? That's 50. Anybody know what type of angles those 50s are? And I joked about it at the beginning, but see the Z? Those are alternate interior. And then you could have gotten to Y by saying there's 180 degrees in a triangle. Okay? A couple different methods. Anything else I didn't bring up or anything you want to throw out there? Okay. Let's go to a couple more algebra problems before I end it on an honors problem. Do you see your diagram? I don't put arrows on there, but I did give you, everyone see just make sure we can read this correctly. Line AB is parallel. There's my symbol, parallel to CD. So you guys yourself can put the arrows on. And it says the measure of EGA is 2x. Hopefully we're in unit 3 now, and you guys can find the angles we're discussing. So 2x on EGA. And GHC, 5x minus 54. So everyone see GHC, 5x minus 54. Discuss 30 seconds in your group. What type of angles are they? What do you know about them? And what's the equation look like? Go ahead. What type of angles are those? What do I know about them? And set up the equation for me.
Isn't this vertical for this and this is alternate next to it? Oh, no, those are horizontal.
Yeah, those are horizontal.
Good job. I'm hearing everybody in their group. They're corresponding. Means they're congruent. So my equation for number 4, 2x equals 5x minus 54. All right, do your thing. Solve for x. We'll write our justification. We got x equals 18. Parallel lines imply corresponding angles congruent. And number 5 now. We did this a bunch in unit 1. We even had it on the unit test, I think. When angles are in a ratio, in this case, they're in a ratio of 2 to 3. Now, when I go put, let's see, 2 belongs to BGH, me putting a 2 here does nothing. I can't use it in any equation, can't solve with it. Anybody remember how we fixed that in unit 1? What do we attach to both, in this case, 2 and 3, so we can use them in any equation? Or label a diagram. Because look, remember, this angle, it's not 2 degrees and 3 degrees. It's not 4 degrees and 6 degrees. It's not 6 degrees and 9 degrees. But I need to figure out what do I multiply by 2 and 3 to get either them equal or add to 180. And what did we attach with them? Go ahead, guys. What do you have? X is with them, right? So instead of 2, we want to label this angle as 2x. And instead of labeling GHD as 3, we want to label it as 3x. Okay, again, 30 seconds in your group. What type of angles are they? What do you know about them? Write the equation.
They're same side and same side, so it's supplementary.
All right, good job. Same side interior, make some supplementary. So now I should be adding them together and setting it equal to $1.80. You get 36. Then it's this one, unlike number 4, says now actually find the angles. And explain, which we will in a second, but let's find the angles first. So go ahead, plug in 36 into 2x and 3x. And what do we have there? 72 degrees and 108. And our reasoning, parallel lines imply what type of angles again? Hopefully this is repetitive now. Same side. Interior angles are supplementary. I get it. It's a pain today doing this all, but tomorrow it'll pay off when I already know what to write in the reasons column. Any questions before we get to the last one? And what class are we in again? Honors, yes. I don't do this last one in any of my geometry AB classes because this is a little bit upper level. Let me just make sure we're clear. All these special angles we've been talking about today do not exist unless I have a transversal. All right, you probably didn't even notice it, but if you look back on all the examples we did, I always have a transversal. In this diagram, do I have 2 parallel lines? I do, but there's a problem. Is this ray right here a transversal? No, it doesn't intersect the second parallel line. And darn it, how about this ray? Is this a transversal? No. So everything we just did today means nothing because I don't have a transversal. So what I'm going to introduce to you is what's called an auxiliary line, which is an extra line you could put in a diagram that's going to help you. Because right now, could we label some of the angles right now? Like if that's 50, can you label the one next to it? 130, right? And you could probably already label the 2 above, right? 50 and 130 again. But that's as far as we're going. You're never going to make it to the top to get to X. Like that's all I can go. You can't go, oh, those are course. Get that word out of your mouth because we don't have a transversal. So what we need to do is create an extra line here where maybe these rays become transversals. And that extra line is a 3rd parallel line. Now, where can I put this 3rd parallel line so these rays become transversals? Right there. Because now watch. I'm not going to do any math yet, but doesn't that ray become a transversal now? Because it hits it? And I can't get it to go right through. It should go right through where the 2 rays meet. Does everyone see there now? I have 2 lines, and then now that becomes a transversal, yes? Whoa, 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 whoa. Don't. I know you're thinking it, but it's not true. That parallel line is not a bisector. Okay, it's not a bisector. Doesn't split it into 36, 36. Okay, don't go there on me. All right, you ready now? Remember that whole angle was 72. Let's go to, come on, no. Worst time ever to go off. Just about to do something great. Worst time ever. But I'm going to keep my cool. Can I get that back with everything there? Okay, good. Okay, everyone ready now? We'll work our way up to X. Everyone see these 2, my auxiliary and the other parallel line cut by this transversal or old ray? Can you guys let me know what this angle right here should be so I can label it? What should that angle be? Why 50? Because it's either alternate interior with this 50. Look, it's corresponding with this 50. Does everyone see that? This angle here is going to be 50. Are we okay? We see why? Now I have two parallel lines. Now, remember the original angle was 72. So now what's going to be this angle here? That makes that angle 72 degrees. I already have 50. What's the other part going to be now? 22 degrees. Good. Now let's go to these two parallel lines. The auxiliary and the top one cut by this transversal. Anybody see any angles we've talked about already today? You could go a bunch of different places here. What can I do with that 22 to get other angles?
Vertical angle?
Vertical. Where's the vertical?
Like,
Oh, you want to say that this is, if that's X, that's X?
yeah. No, like the one on top is 22. So,
The one on top. I don't see another vertical angle there with the 22.
never mind.
You sure?
Yeah. Okay.
Any other angles we see? Like I'm talking alternate interior, exterior, same side interior. Anybody see anything I can also label using the 22? I don't want to give this away here. Using the 22, what other angles could I label here with these two parallel lines cut by the transversal? Nothing else? Ian?
Corresponding.
Doesn't that 22 and the X correspond? So what's got to be X? Oh boy.
22.
They're congruent. X equals 22 degrees, yeah. So there is one problem on tonight's assignment where you need to draw in your own auxiliary line. And can we just take a peek at the bottom? Brush them off. Brush them off tonight. What do I want you to brush off? What do you have to do in 45? Brush off Yoda's factoring skills, because you're going to have to do that in number 45. We did that in algebra. It's geometry. You need that skill in geometry too to be able to factor. Do we want to review that real quick? And it's not anything crazy. It's the basic of basic factoring. First of all, you're not doing anything yet. You can't start sniffing factoring until, anybody remember, one side? Got to have one side equal to 0 tonight before you factor anything. So make sure one side's equal to 0. Move the 24 over. Right? Not like that. Come on. Act like you've been there. Now you play yourself a little game tonight. Two numbers that do what? And this is the only type of factoring I'm going to require in this class. For now, anyway. Two numbers that multiply to, in this case, the C value, negative 24, but at the same time will add to the middle term. Remember this last year? Yes, no, or they just didn't teach any factoring. All right, what are those magic numbers?
Negative 6.
6 and 4. But again, they have to add to negative 2. So negative 6 and positive 4. And then my two answers. Well, let me slow down. Remember, you set each of them equal to 0. So you get x equals 6 and x equals negative 4 for my two answers. Yes, no, maybe. Hasn't been that long, has it? Please don't tell me they showed you a trick on the calculator. Please don't tell me they showed you that y equals trick in an honors level class. Do you guys know about that? I'm not showing it, but do you know about what I'm talking about, any of you? You go to y equals and do something, or you go to your grapher and do something. Yes, so you do. Oh, God. I'm sorry. I'm sorry. If you can't get two numbers that multiply to 24 and add to 2, we got problems. All right, I'll just leave it at that. All right, so don't skip it tonight, but if you need help, ask it tomorrow. Okay? Or wait, don't you guys, or did you just use the solver last year? You just used the solver probably, right?
Either one. Get the answer.
Okay,
So-
but I again, this is my first year using it, so I totally forget all this stuff. But if you want to use the solver, okay, use the solver. I'm not going to fight it. All right, I'm not going to fight it this year. All right, we're